I'd like to introduce Jari Arkko. Now, I've known Jari for a number of years. We sat on a wonderful committee called the IANA Transition a few years back, where I got to know Jari's, understand Jari's work ethic, and his technical ability is just really, I won't say second to none because there's a lot of great nerds around, but Jari is one of the best, let me tell you. He's a senior expert with Ericsson Research. He's also served as the chair of the Internet Engineering Task Force. So for you IETF nerds, we've got one of the great IETF folks here. Expect him to do a bit of that. And he's a frequent contributor in matters relating to the internet architecture, trends and administration. But one of the fun things I would really like to hear about from Jari is, of course, I know he's really interested in IoT and has done a whole bunch of stuff there. Now, most people just put their dirty laundry out on the internet, but apparently Jari actually controls his dirty laundry from the internet. So in true internet architecture style, he connects, he looks after the infrastructure of his dirty laundry rather than just putting it out there. So I'm going to hand over now to Jari to do his presentation, and hopefully he'll give us a bit of an understanding about how his laundry gets done too. Anyway, sorry, I shouldn't really go there. Let me switch over to your presentation, Jari, so that you can then take over. Here we go. And I believe it's, L makes it go full screen. Something like that. Almost there, folks. And it helps if you press the share button as well.
There we go. And thank you, Narelle. So thank you for having me here to talk about this topic. And good morning, good afternoon. I did want to talk about internet evolution, basically from the point of view of this COVID-19 pandemic this year, and talk about some measurements and observations on what happened, at least in the early part of the year, and also then expand a little bit on like how does the internet evolution happen, and why, and when does it happen, and when does it not happen. I can also talk about my dirty laundry, but I'm afraid it's a little bit simpler than perhaps I have promised. So I realized many years ago that once you connect things, you can actually start to do wonderful things that you didn't even plan on doing, because you have this ability, you have information available, so you can actually track things better. I didn't actually control my laundry. I just was able to track it, like when is it dry. And what made this possible is that if you put sensors all over the place, then you can actually measure things like humidity in the room where the laundry is drying. And suddenly you can actually track the trends and realize that now the humidity is at a level where it seems that no more drying is needed. So that was sort of a surprise that, well, okay, I did these things, and now you can actually do weird things. And that's a simple example. You can do also more complicated stuff. Several of us have been working with AI, and that obviously gives you all kinds of additional powers, but it's all based on this simple idea that once you have data and communications available, then you can actually innovate. But let's go to the COVID-19 and internet evolution talk. I think we can actually pass this slide and go to the next one. So let's talk about some measurements first. So what did actually happen with networks? And by the way, this is sort of from my perspective, and with my data, it'd be interesting to hear a little bit about like what's happening over there in terms of your traffic, or what the impacts were in the spring. But obviously, looking at the effect on the network or the internet of this crisis, you can see many different kinds of impact. One obvious impact is that people started working more from home and were sort of primarily connected through networks and not necessarily next to each other in the offices. So this obviously changes what traffic is going in the network. So we saw like an immediate increase in different types of networks, fixed networks, 30%, 20%, depending on what particular country or situation you look at. Mobile networks, maybe a slightly less increase than in fixed networks, but an increase, depending a little bit on the type of a measurement. Like I believe we did a measurement at Ericsson that said in some cases you went down a little bit, in some other cases you increased quite a lot. It all depends on like, what the prevalence of fixed ADSL connections, for instance, or fiber in a country versus mobile. IXPs saw a big change as well. The picture on the left is a map of Paris, and green means less usage and red means more usage. So this is a map of mobile network usage from the Paris area. You can see that the downtown areas were down. Obviously, people didn't go to their offices, and then suburban or residential areas were increasing because obviously people were at their homes and using the internet more. Maybe we can go to the next slide. And depending on that was just the traffic numbers, but of course, if you look at the individual services or applications, you will see that obviously meeting services or conferencing services were a big hit. So that you was depending a little bit on who you ask, you would get up to 20 times more users or 200% more traffic, and this many billion minutes more usage than previously. If you click once more, then you get a little bit more. Okay, maybe this is a slightly different version of the slides than I actually sent, but nevertheless, it doesn't really matter. If you look closer to the type of applications that people were using, this is research that we did at Ericsson. We talked to 11,000 people throughout the world in different countries and asked them what applications they use. And of course, there was a change in the usage pattern. Quite obviously, like travel applications were not particularly well used because of this crisis. But then, e-learning or remote working apps and wellness apps and, of course, COVID-19 apps were obviously increasing usage. Next slide, please. And there's well, I guess you can say that this is like a fairly big immediate shift. At least in recent history, I can't remember another situation where we had such a big change in the traffic numbers and types of applications. And it went, I guess, you could debate this, and people do, but most of the material that I've seen points to a relatively smooth process. And I guess because capacity was being added proactively, other improvements were being made in the background. Of course, you also have this cloud CD and deployment models, which means that, well, if this app doesn't need our computer hardware now, then maybe you can move the capacity to this other app that does need it. So you can fairly easily scale up and down, and this is actually a good thing. And the internet is also, it's fairly modular. It's not optimized for a particular purpose. It's it works for any application. Maybe not perfectly, but it can also change what it is being used for. So that's a plus. And this isn't visible in this version of the slides, but we at Ericsson did this again in the same questionnaire. We were asking how did people feel about their broadband connections on the fixed network or their mobile broadband connections on the mobile network. And on the fixed network, I think 60% said they were very satisfied with their connection. So yeah, maybe it's a good number, maybe it's a bad number, I'm not quite sure, but it's a decent number. At least it was not a big catastrophe that the network would have gone down because of these events. And the same for the mobile network. I believe the number was 75% felt that they had the same quality mobile connectivity as before or better. But there are, of course, also these long-term impacts. More and more people are using video calls. There's new user groups like the elderly, for instance, were forced to learn these particular types of applications, but now they are familiar with it, that they can actually use it. And same is true of organizations. More and more organizations were forced to use virtual meetings instead of in-person meetings, and we're forced to figure out like how do we set this up and how do we work in this fashion. So I think that's going to have a big impact going forward. Another thing that we found in this Ericsson research was that the consumers were actually quite interested in resiliency. They realized that, hey, this network thing is actually important, and it's the condition for us to be able to even order supplies or be able to do any work. So people have realized that this is like we actually care about that the network stays down. So maybe that will have an impact going forward. That maybe it's not like let's say 50 cents on the monthly price, but they actually would like to understand better that this provider is giving us a more reliable network. So that I think is a useful thing going forward. And maybe we can go to the next slide. I should mention, and this is slightly outdated now, but we have a workshop coming up on the Internet Architecture Board on COVID-19 impacts, and on the URL at the bottom, the deadline has already passed, but the papers will be lots of interesting research, lots of interesting measurements will be available on that link, and you may also be able to follow the discussion in the upcoming workshop. It's on the week of November 9th. Several virtual meetings on this topic, obviously. And so the work that is being discussed there is, for instance, measurements on like congestion and so on in different parts of the network. Next slide, please. And then let's go to the more general topic of evolution. Obviously, we have all seen examples of internet evolving or also not evolving in some cases. I guess the prototypical example of evolution going slowly is perhaps DNSSEC. Very useful thing, very important, but maybe more slowly deployed than people might have wanted to. The same is partially true of IPv6. IPv6 is, at least in my sphere, is like it's very important for me personally in my network. It's also for like our Ericsson customers, like operators who run huge networks and they actually need to address all the devices in the network just internally, just for management purposes, for instance, or control protocol purposes, and that's important. But still, we're at like 25–30% deployment globally, and it's gone very slowly. But if you contrast that to some of the other things, so very recently, a couple of years ago, around the time of the Snowden revelations, we had a big change in the use of encryption on the internet, mostly HTTPS, but also, of course, other types of encryption. And in the networks that I know of, it went from maybe 20% usage, 20% encrypted traffic to 80%. And beyond, I think currently we are inching towards 100%. Or for practical purposes, everything is now encrypted, or almost everything. And that's a huge change. And we'll talk a little bit about how that came about in a moment. Another example is transport protocols. Like, okay, well, we all learned to love, TCP/IP and TCP in particular. I thought 10 years ago that will never change. We'll never get out of it because, just so much deployed code out there. But it actually is changing. So we've seen overall in the web protocol stack, we see the security change, we're also seeing the transport and HTTP changes. So HTTP2 sort of basically rewrote the protocol, even though the service is the same, but it's a very different protocol internally. And we saw the security protocols change internally entirely. We saw transport protocols change from TCP to QUIC. And again, because this is not like a user visible change, so your mom may not be aware that something changed the internet, but it did change, and it's been quite widely deployed. I believe like 50% of YouTube traffic is QUIC, 100% of Facebook app traffic is QUIC, and so on. So it's quite remarkable that kind of change can happen in short order. And again, we'll talk about the reasons for that in a moment. And obviously, there's been lots of other changes. The whole cloud transformation, how people deploy things, CDNs, the mobile revolution has been going on for a number of years, and virtualization, open source, like how you build things, do you standardize everything, and you build open source? That is also an ongoing change. There's also a business change is one of the things that we see happening, and it's kind of a trend that we're basically trying to track all the trends in the Internet Architecture Board. And one of the trends that we've seen and has potentially some negative effects also is consolidation, like bigger and bigger entities are controlling the most of the internet traffic, and it is a worrisome trend. Of course, it can also have other impacts, like sometimes it's easy to deploy things because a big entity decides that they'll do something. Can we go to the next slide, please? Yeah, so speed of evolution. The first lesson, of course, is that what does a particular feature give for me? Like nothing is going to go forward unless I have a reason to deploy it. I being the whoever is in charge of the network or the application or computer, and that is the primary key. But there's also other things that we should talk about, and the claim is here that we actually are evolving much faster now than we were in the past for a couple of different reasons. Version updates, way back, it was maybe a little bit more cumbersome. Today, we have the situation where most of the applications, including browsers, they can change daily if need be, because software update processes are far more sophisticated. You could see this, you can measure this in some instances. For instance, when TLS version 1.2, which was the previous version, got deployed versus what TLS 1.3, which is the current most recent version, got deployed or got developed. And if you compare the first few months of those, then there's far more usage of TLS 1.3 now than there was TLS 1.2 at the same amount of time. So the percentages of the traffic is growing much faster, and I guess partially because of the software update process, but also because of some reasons why this, people actually want to have these features. And I believe like after the first year and a half, 30% of the internet secure connections have switched to TLS 1.3. So it's a pretty good, impressive result. The other reason is necessary enablers. Like sometimes you have these things that I can't do X because there's something missing. One example of that, we didn't have like an easy way to get certificates. Now we do. We have Let's Encrypt, and suddenly everybody can easily turn on certificates and therefore easily turn on security. And this was one factor into this. Why did the security thing change? Consolidation I mentioned. If you own if you Google and you owned Android and you own the servers that Android talks to, well, it's pretty easy to change. The other thing is who can change code. So that's actually one of the things that we at IETF did for QUIC. Like previously, a lot of the changes were like kernel updates, and that's fairly a slow process to get anything to the kernel, let alone update the machines. But if you can put things or push things up the stack to the applications, then you can do things much faster. And this is what QuickDuck does, for instance, like typical implementations is in the application space, and you can fairly easily deploy it on this daily software update if you want. And there's also protocol engineering tricks. Way back, if you look at TCP, we never could change TCP because so many middle boxes were looking at TCP traffic that if you changed anything, your packets would be dropped. And that was a big problem. Now we actually realize this problem and it can be solved. Like these new protocols like QUIC, they actually encrypt as much as possible, which means that middle boxes cannot, even in theory, look at stuff, and they cannot depend on that stuff. Therefore, changes in the future will be faster and easier. There's also other tricks like greasing, where you try to use different features of the protocol so that you can actually you behave slightly differently in different ways. You expose other people's code to this variation, and therefore you can't like have implementations that depend too rigidly on a particular version or particular options being present or not. Next slide, please. So the keys to successful evolution, I guess, it's very simple. Like you have to have, immediate reason and immediate payback. And if you have that, then things will happen quite rapidly. And like if you compare IPv6, which there's a very good reason why that needs to be deployed, but the payback is not necessarily immediate. Versus if you look at like TLS 1.3, which is just a HTTPS security protocol. But the trick with TLS 1.3 is that it actually shortens the latency of the connection setup. So it is better from a security perspective, but it's also faster. So you bundled efficiency and security together, and now people are very keen on deploying this because I can cut down on my number of packets. I can get the content to my users faster. Pretty much the same reason also in QUIC and HTTP2, that they also had this idea that we can perhaps do something on the first packet instead of having to wait for complicated handshake before anything can happen. Let's see if I actually missed something here. So the one that's at least on my screen hidden a little bit by the video screen is this long-term maintenance. And I don't know if anybody of you followed the links panel discussion last week with Jeff Houston, myself, Andrew Sullivan, Casey Claffey. And one of the things that we were discussing there is that some of these internet improvements are like spinach. Like, not everybody may like spinach, but it's actually good for you. And I don't know what they're actually talking about because I like spinach, but I also like IPv6 and DNSSEC. But the thing is that you have like this, short-term thing that if I eat steak or drink champagne or eat cake, then, immediate gratification, it's like immediate benefit. And spinach is, at least according to some people, it's like, oh, it doesn't taste so good, but it, long-term, it's good for your health. And we have a little bit of this issue in the internet that it's easy to do these things where there's an immediate payback, but it's harder to do these long-term changes that would, improve the health of the internet, except when you can actually bundle these things together, like we've done with TLS and QUIC. Next slide, please. So that's about the evolution. I just want to talk about upcoming challenges a little bit, and there's a bunch. Didn't want to go into too much detail here, but talk about security. Obviously, that's hugely important, and we've been, I would claim, very successful in the last 5 years in implementing security because of this HTTPS huge deployment change. But we are realizing, I guess, that it's not just about communications, because most data leaks in the internet happen through the servers, not not through the communication, for instance. And that's a thing that we have to take far more seriously. So do you actually want to share a lot of this data that you are sharing with entities in the internet that you don't really have a proper contract with, and they may not be respecting your rights as a citizen? In fact, they might not even think of you as a customer. It's more like a data source, or you are a data source for them. And that's the thing that we actually have to now take more seriously, because the other leaks have been largely blocked. Communication cannot be spied on easily anymore. But we're still spreading a lot of information in the internet to insecure places that we should not really trust. What can we do about that? And there are things that you can do. You can minimize data. You can design your infrastructure in a manner that they don't automatically generate this data source for somebody to mine commercially or otherwise. I think we're also more interested, like I mentioned, this interest from the consumers, that they want to know that their networks are actually resilient and reliable. So I think we're seeing that for a number of reasons, like COVID-19 realization is one of the reasons, but also there's lots of industries that want to use the internet or mobile networks or networking technology for critical applications. And then the prospect of resiliency and prospects of possibly being attacked in some fashion is hugely important. So I think we need to work on that. Obviously, performance is important, continues to be important. You saw some of these examples where changes can actually be deployed through performance improvements. We need to continue that. We will have a more diverse situation with devices, because we have like more and more powerful computers, but also more and more of the simple devices that have like a very different user interface capabilities. So essentially no user interface capabilities. Like the sensors in my house, they have like no keyboard, no display, no button, no nothing. So it's quite challenging. Consolidation and centralization are issues, and I just want to explain briefly what I mean by this. So consolidation is this business process where more and more your traffic goes to one place, or one place and another place and one CD, and then that's it. Centralization is related to that, but it's this model where instead of having this distributed internet, you suddenly have like all your DNS traffic goes to Quad 8 or similar. And that's also harmful, because it creates these points where you might possibly have a failure that would affect a lot of people. You might have a situation where you can collect more data from these points, or governments come up and ask for the data. And we as technologists or service providers can do very little to refuse those kinds of commands. I could mention about like what's on the right, QoS, clean slate, and so forth. I think I'll just leave it at many of us have had a lot of experience with like looking at internet architecture in some different ways, and proposing some improvements or changes, but then realizing that it's quite hard to get these clean slate deployments in place. So at least from my perspective, Evolution seems to be the model that actually works and gets stuff deployed. And expecting revolutionary changes maybe not so easy. Next slide, please. So when you look at stuff that people propose, and people propose stuff all the time, like the academic community has, this idea, that idea, and various companies propose, and various competing SDOs perhaps sometimes propose things. There may be a recent example that I'm thinking of, but don't want to dwell on that too much. But the thing is that you need to look at this, all of these proposals in a critical fashion. Don't believe them immediately. So there's some warning signs. So if there's no involvement from those people in this proposal who would have to change, like you want to change the internet, but you never talk to any application developers, maybe not such a great idea. if you plan to do like, we are going to command, we are, some organization, and we're going to command you to do this, probably not going to work well. There's lots of cases for us that the engineers sometimes claiming that, obviously we need X, but we don't actually justify that in a rigorous manner. I think we need to. We also, the techies sometimes misunderstand or just simply ignore business aspects. Those are hugely important, as you saw from some of the previous examples. That, why would I deploy this new protocol? Well, because you can get one round trip less for your users to see your stuff. There's also cases where there's some deployment incentives that exist, but they could be in conflict with user interests. Like, this party wants to do, I don't know, more massive surveillance of its users, but that's obviously not in the interest of the users. So that's a thing that we have to sort of actively watch for. And the details also matter. Like, you have to look at this, like, my mom knows that there's security problems in the internet. She doesn't know how to fix them, but it also feels that sometimes we have like this world where lots of people who are proposing things are not necessarily understanding how to fix the problem. It's not enough to say that, well, we have this problem in the internet with security or performance or whatever, and we need to fix it. Well, yeah, people have been thinking about this for decades. Come up with a solution that you can actually show that it works and you can deploy it, then we'll talk. And if you look at the details, sometimes you see, like there was this proposal that's been discussed this year from somebody about various things, including better security. But if you look at the details of the security, it's really a replacement for this communication security and not an upgrade to better security for the things that we are currently missing. And even if you look at the communication security, it turns out that it was simply the same security level, but then they added somebody who also has the keys. And so now you have, not just you and Google who know what's going on in your YouTube discussion, but also a third party, which may not be good. So do take a look at the details. Next slide, please. So the summary, hopefully we can discuss this a little bit, and your experiences over there, or in general, and fate of the internet. But from my perspective, at least, the internet is alive and kicking. It's evolving more rapidly than before, and we have clear proof that we can do fairly rapid changes, like in a matter of years, and massive changes that basically impact almost everybody or almost all connections. That's remarkable. And of course, the other side of the coin is there are these other changes, eat your spinach type of changes, perhaps that is going slowly or will not happen at all. But it's very difficult to force people to do stuff. So we should not even think of that in that fashion. So I'm excited by this actually. Like I think lots of things are happening, and they are the ones that people actually seem to be needing. So that's good. So looking forward to what's going to happen in the coming years. And the final note that I talked about in the previous slide was, don't believe all proposals or claims about the internet or changes to the internet. They may need more critical review in a lot of cases. So that's it, and I think I did fairly well on the time. I hope so, at least. And we have plenty of time for discussion and questions. And I'm not sitting here and claiming that I will be able to answer lots of questions necessarily, but discussion is welcome.
So we have one question for you, Jari. What are your thoughts about public disclosure of security issues and how that impacts the overall security compared to companies just fixing and not publicly disclosing?
Yeah, it's a good question and a complex complex issue. And of course, like if you're a security researcher, you should do a responsible disclosure and leave companies and people time to fix their systems and before you release it publicly. But other than that, it is actually a very important part of the process that we are public about the security issues. How would we ever fix anything if it wasn't really public? And I'm also very worried that in a lot of cases there's this market for new security vulnerabilities, and they're being used by criminals, surveillance organizations, sometimes even the police in some legal fashion in some places. And it's not a good thing. It sort of creates this incentive where there's this dark market, and there's lots of hidden things that get used instead of getting fixed. Because like if I'm a security researcher, I find out something, should I sell it to those people with I would get some money, or should I disclose it or tell it to the manufacturer and then disclose it a couple of months later and not get any money except maybe a little bit of fame? I'm disturbed by this. So I don't know what the answer is, but it's certainly an issue. This overall hiding of security faults.
Next question we have, any thoughts on how you might get a more diverse level of stakeholders involved in the IETF process?
Yeah, that's a good question, and there's multiple possible answers. One answer, of course, is that it's already fairly diverse, at least in terms of like there's usually like there's at least some operators, there's different players, like there's the browser manufacturer and the server owner, and then there's a security researcher, and then there's different type of network people. So that's a good thing. It's an open process, so anybody could in theory be involved, but it would be, I think, challenging in practice for, I don't know, a government person, for instance, or regulator, or even like you're running a particular network somewhere and you're very busy. Like how do you get involved with people who are essentially professional standardizing people or professional developers for a particular thing? Their bandwidth for dealing with stuff is far larger than what small number of hours you can perhaps spend on an issue. So there's like a mismatch between the capabilities that I don't have time personally to be involved in all of the IETF discussions that I would like to be involved in. I guess the issue is the same with lots of other people, or even worse.
I think we can all relate to that.
Yeah. Are there any other questions that we have from any attendees or anybody here in the room? Because I've always got questions. Anybody else?
There's no further questions coming from our attendees at this point.
I wanted to add to the observation you made here about traffic, the way that different traffic patterns changed over the lockdown period that we certainly had earlier this year. Hopefully we won't see too many more of. But different networks that we had also went from being net providers of, or they became net providers of traffic, whereas previously they were net consumers of traffic. So for example, the university sector went from being a net consumer of traffic to being a net provider, as everybody went home and started giving lectures online and watching lectures from their home ISPs rather than their work ISPs. So that was an interesting one. A question actually that I had for you was about IX evolution. Do you have any thoughts on how you think the internet exchanges, such as our own, operate? How should we evolve into the future rather than just being, a big fat switch that passes traffic? Well, the big network switch anyway. But should we be adopting SDN and ripping apart the layered model and going for all sorts of new services? Have you got any ideas on that front, do you think, for the IETF?
Yeah, it's a good question. I'm afraid you guys are maybe more experts in how you should evolve the IXP business. Unfortunately, so I think first of all, like this, like we've seen this, like what you mentioned about the universities. That's a thing that's occurring in a lot of different places in different ways. That like the entire direction of traffic changes. Like, wait, you were only downloading stuff at your homes. Now you are. Maybe in a lot of cases, you're uploading quite a lot because of your conference calls. So that's been very, very visible change. With regards to the IXPs, I mean, I guess there's different futures are possible. You could imagine that there's like this, services that IXPs could be offering, going forward, some kind of higher level, application level, someone mentioned SIP interconnectivity, maybe. But I think it's also important to remember, like you have a very, very important function at like you're just doing the connectivity. And I kind of relate to that a little bit in the same way that I relate to what is going in the telecom industry, which is my day job, and they often dream about stuff, but we need to have these and these and these services. Well, yeah, maybe, but also other people provide services, and maybe you should take care that people have enough bandwidth available and at an appropriate price point, and that the resiliency is sufficient. So maybe that's an area where lots of IXPs should be thinking about stuff like, how can we make sure that our systems are resilient enough to be able to withstand different kinds of situations. The COVID was kind of like, from a networking perspective, it was a big change because of the traffic directions and amount of traffic. But it was also a case where we had lots of things, many things were retained and nothing really broke as such. You could imagine, like, I don't know, natural catastrophes or the like, where things also break or become inaccessible, and being able to deal with that and understanding the impact of your service to the societies. Maybe that should be thought even more. And you probably have already thought about this well enough, and you're more than well prepared for that, I hope. But I think a lot of organizations in the world are thinking about that at the moment. Or how prepared are we for that, for different kinds of eventualities?
Yeah, it really has been a time that we've managed to test all of our networks completely to see the full extent of their resilience, and test our own teams, to test how resilient our own teams are in the context of all this. It's just been a phenomenal time. So I'll just ask if there are any further questions from any of our attendees. If there are any other questions to put to Jari?
No questions yet.
Okay, I'm not hearing any questions or seeing any in the chat either. So on that case, I'd like to thank Jari for getting up at what I know is what they call an ungodly hour of the morning for you. I really do appreciate it, and I will happily return the favour at any time you'd like us to. I'll find somebody else here if I can't do it. So I really do appreciate the time that you've taken to present to us, Jari. It's indeed been a great honour to have you. It's just wonderful that we've been able to bring together the different levels of expertise across the world during this time, actually. So once again, a huge thank you to you, Jari. I'm sure that's been coming across with acclaim. Those of you with emoticons can probably hit the right emoticon and add a clap symbol to the screens. I won't try and find mine at the moment. So that's then, once again, thank you, Jari, for giving that great presentation.